Alright, so today what we're going to do in this video is we're going to try to get the domain and range of these functions I've created and express them using interval and set builder notation. Later on, we're going to check our work by seeing the graphs of these functions just to make sure that we did them right and to reinforce our learning. So let's get started. So the first function we have is x minus 3 squared plus 6. Now, you should remember that this is in vertex form. What this means is this gives us the vertex of the parabola. It gives us the vertex with this 3 and this 6, remember? So what we're going to do is we're going to first find domain of the function. So as we know with parabolas, the domain of the function is x is the element of real numbers. The reason being, we can put x in here and there's no value that is restricted here. So for interval notation, we write x is element of the real numbers, and we're done. Now for set builder notation, we should know how to do this. It's the most basic kind. So we have open bracket, negative infinity, comma, infinity, and then we close it with another open bracket. These open brackets are just to tell us that infinity is not included, because infinity is not a number, it's just a concept, and we can never include infinity. That's good. This is for our domain. Now let's check out our range. Now, as I said, this is our function in vertex form. Now in vertex form, remember, a parabola, it opens up like a U because it has a positive sign here. So a parabola is going to look something like this, right? It's going to open upwards, and this is the minimum point. We're trying to find the lowest point here. And because this is a parabola, we can get the minimum point by looking at the 6 here. This is what we look at to get the minimum point. So this part, x minus 3 squared, is always greater than or equal to 0, right? Because it's 0 when x is equals to 3. So if the minimum value of it is 0, that means the minimum value of this part is 0. That means that the minimum value of this entire function is 6. Thus, y must be greater than 6, greater than or equal to 6. Y is also the set of real numbers. So we can simply write it like this. Y is the element of the real numbers. And we have the slash for a condition. Y greater than or equal to 6. So that should be pretty good. Now for set builder notation, it's pretty simple. So we have the closed brackets. We start from 6, comma, and on to infinity. So that should be pretty simple. We've done this in grade 10, I believe. So we have our interval notation here for the domain and range, and we have the set builder notation. And let me clear the board here. And let's move on to the next one. Okay, oops. Okay, so our next function, we have square root of 9x minus 3. Now remember, for square root, the input here must be greater than or equal to 0. Must be greater than or equal to 0. Now, it might not be obvious at first, but what we should always do with square root function is we should factor the inside if we can, so that we get something like x minus a different number, because 9x minus 3 is probably not the best thing to work with. So if we factor this, we get square root of, we can factor out 3, then we have 3x minus 1. Now 3 is just multiplying what's inside here. Everything inside here is just multiplied by 3. So what we have to do is find when this is equal to 0, and then we can work around it. So clearly we have 3x minus 1 equals greater than or equal to 0, right? 3x greater than or equal to 1. Then we have x is greater than or equal to 1 over 3. What this means is for this square root function for the domain of the square root function, x must be greater than or equal to 1 over 3. Now think about it this way. If we put, for instance, x equals 0 in there, we get 9 times 0 minus 3. Then we get the square root of negative 3. Clearly, that is not defined. But we put something such as x is equal to 1, we get 9 times 1 minus 3, which we get the square root of 6, which is valid. So we're going to write in our interval notation, x is an element of the real numbers such that x is greater than or equal to 1/3. With set builder, we do, because this is equals, we can do close brackets 1/3 and all the way up to infinity, like that. Now for our range, we should always remember that the square root function, the minimum value is 0, right? Because the minimum value that we can put in for x is 0, and the square root of 0 is 0. And as our x increases, our square root function also increases. So the minimum value of our square root function is 0. And notice that we don't have anything else behind it, such as a +5 or something. So this square root function is just centered at 0. So what we can write here is y is an element of the real numbers such that y is greater than or equal to 0. And for our set builder notation, we simply write close bracket because because square root of 0 is 0, and this goes all the way up to infinity, like that. So that should be pretty good. I will clear the board now, and we're going to move on to the next function. All right, our next function, we have negative brackets x plus 9 cubed minus 2. Notice again that this is what we technically vertex form is reserved for parabolas, but we can think of it in the same way as for cubics and other polynomials and parent functions. So these give us what these two values give us is the center point of the graph and how it's shifted. So this +9 means that this function, it moves towards the left 9 units. The -2 means it goes down 2 units. However, we should still remember this is a cubic function. Cubic functions, they have no restrictions on their domain and range. So we can simply write x is an element of the real numbers, because all real numbers can be put in here. Set builder, we have close bracket, negative infinity, and infinity. Similarly, for our domain, there's no restrictions here, so we can put y as an element of real numbers. And for our set builder, it is the exact same as the above. Hopefully that was pretty straightforward because it's the cubic function, very simple. Okay, so let's move on to the last function. Our last function, we have an exponential. So notice that this is base 3. It doesn't really matter in this context, but it's just nice to know. So our parent function for this would be 3x. Now, we all know that exponential functions, their values are always greater than or equal to 0. Well, not equal, it's just greater than 0, strictly greater. The reason being, regardless of what x you put in there, you'll never be able to get a value of 0. Reason being, well, the closest we can get is if we put negative infinity in there, right? A really, really negative number. What that does is it turns this into 1/3 x. However, this is always greater than 0, right? Because this thing is just 1/3 multiplied by itself a lot of times. But 1/3 multiplied itself a bunch of times is never equal to 0. So keep that in mind. For the domain, we should note that there's no restrictions on this. So we can simply write x is an element of the real numbers. And set builder, we've done this many times, negative infinity to infinity. Now for our domain. I said before that it must be greater than 0. So this value, but however, we have 5 here. So we just have 5. We add on 5 to both sides. So we get something such as 3x plus 5, because we can add 5 to both sides, and it's greater than to 5. Now, since this x plus 1, the x plus 1 doesn't really change the domain, the range, right? It only just moves the graph left or right. So really, these two have the same range. So we can substitute this for the domain here, for the range here. So 3x plus 5 must be greater than 5. So we can simply write y is the element of real numbers such that y must be greater than 5. Right? Y must be greater than 5. And for our set builder notation, we must remember that because it's greater than, not greater than or equal to, we have the open bracket. So we have 5 and we have infinity. So hopefully these questions were pretty simple, and I'm going to be moving over to our graphing calculator to make sure that our interval notation, our set builder notation, it matches up with what we see on our graphing calculator, just to make sure. So here I'm on Desmos. This is an online graphing calculator that you can input your functions in and you can visualize how they look like. It also has support for other functionalities, but today we're going to be confirming the answers that I gave you in that in the previous section with Desmos, just to make sure, right? And sometimes you'll be looking at graphs and you'll have to write down the set builder or interval notation. So it's good to have practice with both. So these are all of our functions that we had before, and I'm going to turn on the first one. Notice how the vertex form is 3 and 6, right? Just as I said before. So our domain, if I zoom out, you see that there's no, you can't really see, but you notice that there's no value that it can't acquire, right? It's just that it's really difficult to see on Desmos because of the scaling, but take my word for it, it's correct. So if we zoom back in, we also see that there's no, as we saw before, if you caught in the segment where I was zooming back in, we didn't see any value below 6, right? This is because a parabola it points upwards, and this section is always greater than or equal to 0. So our domain is x is the element of real numbers, and our range is y is the element of real numbers such that y is greater than or equal to 6. Let's look at the next function. It's a square root function. And as we can see, we have 0.333. This is because this is a square root function. It can only accept positive values inside of the square root. And as we solved before, we saw that if x is greater than 0.333, this value is always greater than or equal to 0. And notice that the range is greater than or equal to 0 as well, because this thing, it would be, if it was just a normal square root of x, it would be centered at 0. But all we've done is just shift it to the right. We didn't do any up or down movement. So the domain is x is the element of real numbers such that x is greater than or equal to 1/3, and the range is y is the element of real numbers such that y is greater than or equal to 0. Next function, we have this cubic. Now cubic, as I said before, there's nothing real special about it. The domain is x is the element of real numbers, and the range is y is the element of real numbers as well. Okay, for our final function, we have this exponential. Notice how this line, you look at the y value, notice how it's just 5 all the way across, right? It never goes below 5. Now, this is a problem with Desmos because scientific calculators, they're not 100% accurate. But this should never actually be equal to 5. It's just that the value, when we put for instance, negative 180 into x here, 3 to the 179, that's really, really small value. And Desmos doesn't have the capability of displaying that really small value. So it just basically drops us to 0, and so that's why we see 5 here. However, in reality, this should never be equal to 5 here. Our domain is pretty obvious by how the graph looks. It's going to be x is the element of real numbers, and our domain, as I said before, is just y is the element of real numbers such that y is greater than 5. So I hope this video is helpful in letting you learn how to write the set builder and interval notation of certain functions, and how we can confirm our answers by looking at the graphs ourselves.